Okay, we'll start with Victoria. Yeah. I think she's coming back. Okay.
And or how to use them. Yeah. Are you going backwards too?
No, this time I'm gonna go about place because last time I went reverse. Yeah. All right, we'll start with. Likely so, yes.
Yeah. Still has a few more back about the extension. Which makes me think of. True. Oh, there are my desks in that way. There are my desks in that way. They're like delicate.
Okay, we'll take a look at the ramp first. I think that the ramp here still needs to be graded, I believe. Because currently what I'm seeing is no contours that are not connecting across the ramp. So I explained to the class last Tuesday to be able to know whether or not you did it correctly for the ramp, you have to confirm first whether or not your top FFE and bottom FFE are correct. Okay. So if your FFE here 1098, we have to get down to 1098. No, below 1098 somewhere. Not sure what this is yet. I think this is the stairs. You will need to get down to the bottom of the ramp here. And the ramp, bottom of the ramp should be, if you are doing a 2% slope, the spots along this line that is parallel to the building would be the same elevation, right? So you would calculate based on this distance, what your bottom of ramp would be in this location. So if this is 1098, that might be close to 1097 here. So we're getting down to 1097 somewhere here. And then you have the spots calculated, but unfortunately it's backwards. You know, this is lower, okay? This is correct of how to calculate these spots. You need to base that on the distance to your 1097 contour. So this will be below 1097, 1107. So it will be 1106, for instance, 0.8, something like that. So then you start with this and you go for 5%, right? So in this case, 5%, you will be, offsetting a 16 feet to your 1106 contour. Does that make sense? Mm-hmm. And then you go, 20, 20, 20, okay? And here you go up from this spot, whatever the digital here is based on your calculation, and you calculate 1098, right? And then whatever in the middle when you're turning, that can be, doesn't have to be the exact 2%. It can be around 2 to 5, or even from 1.5 to 2 might be acceptable. Better be above 2%, but this portion will be flatter wherever these two slopes turn. The ramp turn. Okay. So that's how you basically, draw the contours out on the ramp. So once you have those contours on your ramp, for instance, if we have 1106 here, you will need to turn your 106 and then figure out a way for this contour to hit the wall. Does that make sense? So all these contours, they need to be modified. And I'm seeing the 1105 connecting to a wrong contour. It should be this one, right? So the 105 might be something like this. Does that make sense? And then this goes up like that. So you have these, and then you need to figure out a way of how do I connect these contours back to the contour segment along the ramp. So that's basically how you do the ramp contour. Okay?
The stairs, like, does it work the same way as if it's-
This is a wall here.
Okay, that's. Okay.
This is a wall here, and then you will be designing your stairs in the middle of here. Okay?
Great, thank you.
Yeah. You do need to, once you measure out these and you measure out these and you test the slope here, you will need to decide this if this is long enough. Okay, if it's not long enough, you need to make it longer by perhaps doing this. Okay, all right, so that is the ramp. Key thing, knowing how to calculate the corner based on the plaza, how to calculate the bottom of the ramp based on the bottom plaza. And then starting from both ends at the top and the bottom, and then see if things agree in the middle. Okay, so that is the ramp. And then I'm gonna go to the other locations for the ramps. Yes, you would need a ramp somewhere here. I would switch the all of these are ADA. You have 1, 2, 3, 4. Okay, that makes sense. Okay, so you do need a couple ramps. One over here, that's your first one. Unfortunately, you do have more. Well, actually your ADA spot is larger than, oh, it's shared by 2 of them. Okay, that's fine. So you would have 2 of the curb ramps looking like this there. You would need a ramp over here, need a ramp over there. And this ramp will take the form of this type. Does that make sense? Yeah, okay, so those are the ramps.
Second one on it, cause like it gets really.
Yeah, yeah. Yeah, definitely needing leader lines here. I like to do that. I like to reorganize all the spots at the end because I need to make sure that I have all the spots sort of, noted first, and then I would be able to estimate how much space I have, right? You don't want to arrange for the first round and then I find out, oh, I need 2 more spots here, and then I need to rearrange them. Okay. All right, so those are the ramps. The divergence swell is another thing that we need to review at this time. The shape, the rough shape is reasonable. I think you might, oh, okay. Yeah, the rough shape is it's reasonable, but you do need to polish them later on. Once you figure, I would start with the retention. Making sure that, for this one, it's only a small area, so it's pretty small, that's okay. That one too. Once you get down to here, you need a bigger one. I probably would add another one over here. I would add another one over here just to, once we get down to the drop off, you have a lot of water to treat. So you want to try to manage the ones that are, before you come into the drop off. You don't have a lot of water sort of, continue to concentrate in this area. So I would add something here. Just to, because you need fewer here, but you need more down at the bottom. Once I do that, then I would start modifying my shape. Okay, so this one actually needs to be dragged up, and this one, same thing. this one is done correctly, because you know, this, the tip of the swale needs to exceed the edge of the bioretention. So this one is good in terms of shape. That one is good. Okay, the last one, this one needs to be dragged up quite a bit. Okay, so that is the divergence swale. And then I see a question about, yeah, I don't think you need another thing here. I would clarify with Stuart what he meant by having this markup over here. You don't need another one because you're not getting water anyway, right? But what I do think you need is high spots. You know, you do need a high point between these two, between these two. Both of them are 1107. Okay, so that is that. And question about whether, yeah, you definitely need the one because you have a lowest point over here. So this water, once you get past of this DI, everything else is actually concentrating down to the bottom here. Right? The location is actually here. Right at the swell. So you need to cut it open and then add this one. Yes, and that is this question. Let's see. How far away? Well, you have enough distance between the wall and the vegetation, but I doubt that you need all this wall length. You know, you would want to try to connect this contour, well, for instance, the 1107, let's find where 1107 is. Distinguish your major and minor, and these contours need to be dashed, okay? Seek some help from Jonathan in terms of the line weight. Because of that, I'm not able to see which one is 10 or let's see, 5, 4, 3, 2, 1, 0. This is the 0. I don't think you would have difficulty, you know, connecting at least, no, for 9, you should be able to connect. Even 10, maybe you would be able to fit it in. So the 9 contour goes out here, and 8, 7, you definitely don't need this portion. You would try to offset. Now close this out and then offset these contours to find out if you need this wall at all. You seem to have enough space in between these contours. If not, you might need just a small segment, and then, for the other contours, you should be able to connect back to. Well, you need to offset these contours. So you need to do the 2 things, working with both this side and that side, right? So first you work on these retention area, and then you draw these swells, make sure that this is at least 4 feet, and then, you have to have these contours in. This one is okay. This one is okay. And that one is okay. This one needs to be dragged up. So try working from this side as well. And you can see, you kind of start to stack these contours, right?
Yeah.
So this is I think this is the 11, and this is the 10, and this is the 9. 12, that's 12. Well, it turns out you actually have all the space that you need, and you don't need to have a wall.
Okay.
12 goes out here, right? So if my estimation here is reasonable, if we stay 4 feet away from each other, you can see 13, 12, 11, 10, and 9. They seem to have their space. Okay. 4 feet apart. If you have a little bit of difficulty in this area, you will put a short wall here. and that should be enough. Okay. So that's about the wall. Anything else?
No.
So I am seeing a few things here. You definitely need to keep moving some of these contours.
Mhm.
Okay. And yeah, overall the drawing is pretty light. You need to increase the line hierarchy for the contours. And all right, we'll move forward then. Okay. So I want to ask if Martina actually got a review already from Tuesday. Is Martina here?
She said it does.
Okay. She probably already got a review on Tuesday, so I'm gonna. Is David here? David here? All right. Brianna. Okay. Let's see. How does the retaining wall at the back plaza work? Is it steps? Yeah, it is stepped. Okay. So the wall have to be stepped because every segment of the wall is, the maximum height for it would be 4 feet. But in this class, we're not expecting you to label every top of wall and bottom wall for the segments. Okay, so we're simplifying that requirement, and we only require you to have 2 spot elevations for for both ends of the wall. All right, that's a really great question. So basically what you have here, you have a T wall and the B wall and T wall and B wall here, and that's what you need for the walls. But you do need to stick to the 4 feet maximum height rule, okay? Do the stair platforms? Yes, a 2%. Yes, correct. Confused on the ramp flares? Okay. You do not necessarily need to calculate the ramp flares. Let's see. Let's try to find one. Here. All right. So for this one, you actually chose a wrong type of, okay. Actually, you have the right type. You have the right type, which actually made it sort of, you have to enlarge this sidewalk area to fit it in. In fact, you could choose the other type, okay? You could choose for this type of ramp where folks get in from the middle. Let's see. I would put this shading kind of together. Okay. This is where people get off, and that's where people park. And then I would do a landing here. And then the ramp will be here. So basically, you do not have a curb here. You roll into the landing, which should be 2%. Sort of an extension, okay? It's an extension of the plaza. Not plaza, sorry. Extension of the parking area. And then you go up to the plaza here. And here you go down to the landing. Okay, so you would have a retaining wall here, but you would only have one line here. Not a retaining wall, like the curb, right? You have a curb over here. So this is the second type of the curb ramp. Okay, it's different from the basic type what you drew before. So this is a simplification, but I want to also take a look at what you have. So you have a basically you need, this is one line, okay? There's a one line, and then you need 2 more lines, and then this is the bottom of the ramp, that is the top of the ramp. And then you need a So this is the flare. The maximum slope here is 8.33%. If you have a 4.17% over here, I guarantee you, you would not exceed the slope requirement for the flare. So you don't necessarily have to calculate it, okay? You do not have to calculate it, but you do need to label top of the ramp, bottom of the ramp, and the ramp, the slope on the ramp itself. Does that make sense? And I'm a little confused why you would have a 8% slope here, but instead of 4.17 over here. It feels like, you know, we've gone the same distance here. Most likely you have an 8.33% here as well. So there might be something that went off while you were calculating the slope here. Okay. And I don't think you would have the same TR, you know, on top of the ramp at 1109.00. This might be an estimation, but what I would do in terms of calculating if your if your sidewalk design follows the parking lot design, you actually calculate this top of the ramp just based on, you can calculate it based on the parking lot, and then you just add the curb. Does that make sense? Yeah. So this will be different, right? These top of the ramp elevations will be all different. It would not be the same. Right? So you just calculate to the next contour and you add the curb height. All right? Unless you chose, oh, I'm gonna actually turn the contours on the sidewalk, then it will be a little different. Right? You would calculate based on, you know, you will calculate based on the contour on the sidewalk instead. Well, so you first need to decide, okay, how will my sidewalk be graded? Okay. All right. So that is about the ramp. I think I answered all these questions, but I want to check the ramp again here. First thing I noticed is that you need a side slope. So you would want to turn it a bit to the side and then go up, okay? And yeah, this is the right direction. Yeah, right direction, okay. Let me zoom out a little bit and see these contours. I don't believe you need all these swells here. So you could actually simplify the contours here a little bit. You can end your plaza retention somewhere here. Okay, you do need one of these. Reason being, the swell is going to have, you know, direct a lot of water downhill. You would want to try to retain it, you know, before it flows downstream. You do not actually want the swell to continue. Okay, you want it to be intercepted and slow down, and then the contours below can be more like this. Can be more like this. So it's more of a sheet flow down instead of, you know, instead of creating another swell. Okay. And let's take a look at the ramp, top and bottom ramp elevation here. So this is 109, 1108. We need a top of ramp elevation here. It seems like you have it close to 108. I have a little bit doubt on these calculations. We will need to see. Okay, the 08 kind of comes down here. All right. Well, you would want to, okay, calculate this all right, based on the distance. Based on the distance, and it seems like the corner elevation is a little low because I think this would be no at about 0.6, okay, 8.6. But this at about 3 is reasonable at this point. And then using these to determine where your 1108 would be, okay? And then your 1108 here can connect to the 1108 over here and then hit the wall, right? So calculating this segment is actually very important and it should be determined by these, all right? And then you decide on how do I connect that and connect this, all right? So that is the top. Let me go to the bottom. So top of the FFE 110, well, because your elevation, along this is sort of between 1110.1 and 1109. So I think this is a little too high. Okay, you do not want to create another step, right? You just roll in if folks are on wheelchairs. So I would say, anything between 1110.1 and 1109 would be fine. Okay, lower this down by 0.5. And once you lower it down, you would know, okay, the bottom is the same thing. Okay, you would want to roll out as well. So you have 1100.10, that's reasonable. Okay, so the bottom actually works because you dropped by 0.5 again, right? So this works. And your next contour here, we're missing some of the contours on the plaza here. Your next contour should be 199, right? 1099. So somewhere here, you would have a 1099. And you need to calculate what this is. Okay, what this is and what that is, the bottom of the ramp. That's the 3.33. If these two, well, they would not be the same, right? They would be a little different, based on your grading of the back plaza. And then you use these to calculate what the 1099 is, where would the 1099 here is. So let me zoom out a little bit again and see if at least we have the correct contour number, okay? So that seems correct. 1009. No, actually this should be close to 1099 based on this elevation. Okay. I don't think we'll drop down to 1098. All right. So we're one contour off here. And so your 109.99 should be somewhere here. Okay, that's your 1099. And which means we actually have a even more gentle ramp, which is fine, right? You want this area, these areas to be pretty gentle. Okay. So ramp needs a little bit of work, but I think you get the idea. Okay. That's all the questions you listed. Anything else? You do need divergence swale. So depending on whether or not where your retention area is, like this one, so you might want to drag it up a little bit. If you want to include another one here or here. Either one, I don't think you need both of them, but you need at least one more. So it means that this needs to come up, that needs to come up. Does that make sense? Yeah, so that needs to be revised. Don't forget to close that 13 contour there because you have a 1112 crossing the 1113 existing, right? Okay. All right. Good. I'll move forward then. Vincent? All right. Your line weight. I would say your contours are still a little too light. You can make your background fade out a little bit more, the existing contour, and the proposed contour needs to jump out a little bit more, I would turn, okay, so all your spot elevations actually needs to be, in the same direction. If you choose to line it up, according to this, that's okay. But they need to be, I understand sort of for some of them, you want it to be parallel to the bottom of the page, but the best way is actually for them to be in the same direction. Okay, so for instance, this one, you actually need to turn it. For us to grade it, the easiest way is actually to align everything to the bottom of the page. But I would say it's okay if you want to align that with your parking lot, right? Just don't change directions. Okay, I know that's bad news, but hopefully it's a relatively easy, operation in CAD. Okay, so that is about the line weight question. Let's go from the left. The swale, your swale doesn't work yet. The reason being, you can see, the water goes down and it actually enters your retention. This is dirty water, right? So the whole point of the divergence swale is to say, okay, the clean water should go along the swale and the dirty water needs to be in its own system. So the way to correct this will be doing this. Okay, change the 110 contour shape. Now you can see all the water coming downhill would go to the swale. All right. The same thing, you need to drag this up. If you don't have anything here, that's okay. If you want to add one more here, this needs to be up there. All right, so that's the divergent swale. Okay. Look at the ramp here. So you start your sidewalk here. It's the ramp done correctly, 1109.17. And then you have a bunch of ramp over here. I'm not exactly sure if we need this one. Can you explain why we added another ramp over here? Okay. Not really. Okay. You can make a sort of pretty very well, this 1.48 doesn't drain well, right? So we need at least 2%. Basically, you're trying to achieve, I move into this landing area and this is one line instead of two, and you need a little bit of curve here and a little bit of curve over there too. So you get in, you sort of roll in, and then you have an 8% slope going down there. And by this time, you are at the plaza level. Does that make sense? So everything else would be at the plaza level, sort of, if this is not vegetation, everything will be following the contours. Well, even if this is vegetation, everything above this will be following the plaza design. Does that make sense? So you actually only use a pretty short ramp to get up to the plaza level, and then everything would be following the contours. If I calculate the elevations of this walkway, it will be following these contour lines. Does that make sense? Yeah, okay. So you actually don't need the ramp to have two segments. You have a small ramp coming up, and this ramp is at 8.33%. So you don't necessarily need this long, okay? You can make it 5% if you want, but after this short ramp, you will be at the plaza level. Okay, so that is that ramp. Let's see. Okay, let's take a look at the ramp. You seem to have a side slope on the lower side. I'm not sure about the side slope on the upper side. So, just want to make sure that you have a side slope as well here, okay? Let's take a look at the plaza elevation here. That contour should stop here, okay? And this is 09. That's good. These are good numbers. 1109 works. And then 99. You do not need to drop. Okay, do not need to drop here. And then the reason the 1109.900 on the upper plaza can be reasonable because, okay, let's see. We'll need to double check these. Oh, all right. We are not at the 1108.7, 1109 level yet. So I would say your top FFE should not exceed this. All right. And then
Can I just make that slide?
yes. And let's see. So based on that, we need to recalculate some of these elevations down here. Suppose we're using these, you're at the right elevations if we use these as references. So your ramp is calculated very well. I would do exact 5% max instead of 5.02, okay? And here we actually need to get it down to 2%. The landing needs to be 2. So you need a little bit of a longer ramp. But no, change that only after you verify these elevations. Okay. Yeah, but I think you understand how to do it pretty well. Okay. Next question. Can I drain the bottom plaza and roof like this? Yeah, you can. Bottom the trench, and then the trench is going all down in this direction, concentrating to the middle. That's fine. The water is collected by a trench drain that brings water down. Well, the only thing that I would add is the roof. Okay, you need to indicate where the roof drains. Is it down here to there, or is it actually down here and then getting into the trench drain? Does that make sense? Yeah.
How exactly?
How do we show? Okay. You could show a trench drain just like that. Okay, you can say downspout, label downspout here, and then trench drain over here. That shows your water from the roof. It's going down actually to the bottom. Some of our students have a different design, right? They just design another retention area in the middle of the back plaza. Do this. And then you could just, using a trench drain. Or it could be, it doesn't have to be on the ground, right? As long as you label it. Things like scupper, right? You can have scupper. And then as long as you label downspout, we will be able to understand that is your intention, right? Okay, great. So I don't see anything else. Is there anything else you wanted me to check? Okay, great. I do notice there's a line here. Oh, okay, that. Some of your existing contours are solid. I think this one was an example. So just double check if all the lines are on the right layer. Okay. Great. You're getting close. Next I have Winnie. Okay. So go over how to grade a trench drain and on the process. So I probably need to know where your trench drain is.
It's like where I drew the green line to.
Okay. Oh, all right. So you have something in the middle here that is for this one. And then you have a trench drain that you want to collect water for the plaza. But honestly, this is not the right location, okay? Your trench drain actually is, if your swell is like this, it actually needs to be along the swell line. So I want to mention your proposed contours are also quite too light, right? It's a little hard, and your existing contour needs to be dashed. And I'm also trying to figure out where your plaza ends. If this is your plaza line, then I would say your contours needs a little bit change. If this is your plaza line, these are too close together, right? These contours. If this is your plaza line, your plaza contour needs to be changed. So what I would recommend, this is your 1108, and you want the water to come out there. So let me change the color here. You want your swell line to be like this, and your swell line, no, I think that direction might be better. Like that. So let me change back to the pink. So your 1107 goes like this. Your 1108 here goes like that. So that continues to be, and then this one, you would have one contour like this. Honestly, I would have it hit the wall. Yeah, because you want to have some more space there for additional contours. So I would turn this a little bit. Although that's not, I would turn this a little bit. Okay, so make sure that the blue line is in the middle, okay? The middle of the two pink line kind of divides the angle into two even angles. So then your 107 wouldn't be here because you will be offsetting, right? You'll be offsetting 50 feet. So your 106 only here, and it's gonna be off the plaza. So it can be closer, but it wouldn't hit. It would not hit the plaza. And then after that, you need to figure out where 107 is here based on this line. Right, based on this top of the ramp elevation and then 5%. Okay, then you can decide, okay, 107 goes like that. And then you can connect your 107 down here. I would not even put 107 down here. Reason being, I would want a retention somewhere here at the end of your plaza, right? So my 07 might just go like this. Does that make sense? Yeah. So for this one, if you would, honestly, you do not need a trench run in your design here because your water is all kind of, flowing along this swell and then getting into the end retention here, right? What you can do to help divide your plaza is actually putting something in between, right? In between along the swell. I know this one is for the drop-off area, and you would want well, I don't think this is gonna drop no. Folks are still going to be able to walk pretty well into your building. So I think having something in the middle wouldn't actually hurt anything. So that's my suggestion on how you revise the other half of the plaza, because this plaza has quite a lot of paved area. Okay, do not need a trench drain. Okay, for this one you would design something at the end. the DI here, you do need to cut off your plaza. Now, unless you change your plaza to this shape, if you don't feel like you need that big of a plaza, you can cut it out. So you don't need a trench drain there. If you decide to keep your plaza like this, you need a trench drain out, cutting out from the plaza and then a retention area. Does that make sense? Yeah, I'm gonna go over the trench drain one more time, in case that's what you chose to do. Okay, I am not, I'm not convinced about that. Let's see. Let's see the red line, okay? Should be exercise 4, right? Exercise 4. Oh, actually not exercise 4. Should be the red lines. Group 2, right? You let me, this is number 155. Quite a big file. Okay. I don't think this is saying trench drain here. It says you need trench drain over here, which, okay. And that is only the one, right? Yes, yeah. Okay, sorry, I misunderstood your question. Yes, you definitely need a trench drain over here, just because, you're cutting through, right? You're cutting through your plaza area. So what you would need to do is figure out the lowest elevation here. It's likely going to be 1107.9, for instance, in terms of BC, right? Bottom of the curve. And now imagine I'm cutting, no, this is the plaza. And this is my curb, right? That's where water comes in. And I need a trench drain that is receiving water down here. Okay, so the bottom of the curb here is not the same as the bottom of the trench drain. So I need to drop another 0.5 here. Okay, so the bottom of the trench drain over here would be 1107.4, for instance. All right, and then the water needs to flow, right? Flow down this direction. So I would need to calculate a 2% slope. 2% slope. And then I measure the length of the trench drain. Okay. And then that becomes where my water comes out here. All right. Let's suppose this is about 20 feet, 0.4. So we are at 1107.0 here at the bottom of the trench drain on this side. Does that make sense? Yeah. So you will use that as your new elevation reference. Okay, so if the water comes out at 1107.0 and you need an RDI, you definitely need an RDI here. Okay, the RDI will be below this, right? You push another 0.25 or even 0.5 to get your RDI, and then you use those elevation to design to figure out which contours in here and where the HP needs to be. So your 108 here is too high. Does that make sense? Your top of the water elevation is 1108.07, so you wouldn't be able to have a 108 contour there. Okay, so basically this is gonna be pretty deep, just because, you know, you have, the water needs to come out of the bottom of the train stream. All right. Good. Okay. How would I do a CC at retention here? This is the same concept, right? If you decide that you don't want to change the shape of the plaza by cutting this out, then you need a train train out. Okay, the same thing. You calculate the BC here. You push it down 0.5 to get your bottom of train train. You measure the length of the trench drain, and you do a 2% slope. You know where the water comes out at what elevation. Okay. Yeah, I think reduce the front plaza would be actually more straightforward. You definitely need the DR or an RDI. Okay, either a DI or an RDI. And this is at the end of the chain, so you have to have one of those. Okay. Should I move the LPS? Let's see. So, where should I place it? Not here. Do you mean this LPS or this LPS? Okay, if this is the one here we talked about, you know, let's do a retention somewhere here, and then you wouldn't need an LPS because the LPS ends just before the water enters into the retention. Okay. All right, so that is that. I think those are the questions you listed. Let's take a look at the ramp. We need a side slope. Okay, and then once we have these elevations, so we need to modify some of these contours. So your FFE, well, your FFE can still stay at 8.0, but or 5, but the bottom would be the same, exactly 10 feet down, right? So those are not right yet. Okay, so you need to fix these elevations, and this is too high based on your top FFE there. If your contour here is 1108, this likely is going to be 8.5. So bottom 98.5, and this would be 98 or even below 98. Okay, so again, following the same advice that I gave to other students, you need to start with this. Okay, calculating these based on the contours, calculating these based on the contours here, and then go from both ends, measure where 1107 is, measure where 1099 is, and then go 20 feet, go 20 feet, and then when you get to the middle, you can include a landing area that's flatter. All right. Okay, so that is that one. Also side slope. I don't remember if I mentioned that you need side slope on the ramp. Okay, so that is the ramp. We haven't worked on the ramp over here yet. Same advice. I would move the shading, the painting of the spot over here, so they would share a ramp up. Okay, if you don't have a ramp here, that's okay too. All right, folks can also just use that ramp over here, but you'd have to have a ramp somewhere here. Because you have a retention here, your ramp on this side would be probably in this location. You do not want the ramp to be at the location where you have a lot of water concentrating. Okay. Yeah, that's it. Anything else? We good? Okay. Calvin? Oh, I remember that Maddie needs to go. I'm sorry, Calvin. I'll talk to Maddie first and then I'll come back to you, okay? Is Maddie here? All right. So you do not need a divergence swell on that side. Does this contour needs to be changed? Let's take a look. Well, your divergence swell still needs some work. So don't forget that you need to take care of these contours as well, okay? Cutting off the 13, close it out for the hill, it's important. So this contour needs to stay a little bit farther away. All right, the 12. If you have a retention in this shape over here, again, your contour needs to be dragged up, okay? Dragged up. So water comes in and then it goes along the swell instead of getting into your retention. So that needs to be improved. Same thing, if you are adding one more here, that needs to go up, all right? If you are adding one more here, this needs to go up, right? So I would work on the retention area along the side and then shape my divergent swell accordingly. Okay, so that is that. Let's take a look at this area. Well, based on these contours, and I know that you have more contours that needs to be moved here, okay? No, all these needs to be moved. So very likely you need to tighten up these contours or even include a wall over here so these contours can attach to the wall. Otherwise, you will run out of space in this area to attach the original contours in this area. Very likely so. Okay, very likely you will need a wall. And then next thing, same as other students, we need to look at the contours. Let's see. This is 10, that is 9. Okay. Looks reasonable. And then we go 2%, 5% down. That's 9. And then this one is you're not at 1100. You're actually at 1110. This is 1100. And so these are not correct. Yeah, let me zoom out, see if that's the case. We are going down and then we go up pretty quickly here. So you're pretty high. Yes, your elevations are pretty high. So that's correct. Your BFFE and TFFE are not calculated correctly. So this is 1110. Okay. 1110, and then this is 1100. So all these needs to be revised accordingly. And then your last contour is actually 1099. So we're at 1102 here, meaning that we are still not, we're not long enough yet. Okay, the ramp is not long enough. So go up from here, you figure out where 1100 is, and then this one seems reasonable. And then you decide whether or not you need to make your ramp longer. Does look like so. It looked like you need a longer ramp because we still need to fit 3 more contours here. Okay, the 0, the 1, and then the 99. All right, so that is about this ramp. We still need to work on that ramp and the ramp over here along the drop-off areas. Okay. Yes, the contours should come close together. Likely you will need a wall. Well, you have to fix this. These contour needs to hit the wall like this. Okay. If we have this issue at the end of the semester, there's a category in the rubric that's called drainage. And that's a really big deduction just because water is flowing along the wall. Okay, so make sure, everybody should make sure that you do not have water draining toward your wall. Okay. Anything else you want me to review? Okay. All right, I'll come back to Calvin. Let's take a look at the curb ramps. We'll take a look at the trench drain and then lessen the slope of the middle of the ramp, or would the landing be better? Let's see. 5, 3. Well, if you have 5 or less than 5 all the way through, you do not need a landing, okay? We'll take a look at the ramp first. So you have 1 here. Make sure that you change this to a single line. There's no curb there anymore, all right? And yeah, that's right. Let's see. You have another ramp over here. And okay, you do not need more. I would work on the hierarchy a little bit more. You can see that you have the painting of the parking stall thickest. All right, so that actually should be the lightest. This should be the lightest. And then your proposed contours doesn't jump out yet, right? I think you have a really good grading project here. I would hate it to see that you lose points on the representation. Okay, so we answered this one. Let's take a look at the trench drain over here. This one, yeah, this one works. Yeah, you work on, well, you need to label this as bottom of trench drain, okay? Bottom of trench drain 1106.00. That works. And then RDI, sure. LP. Well, your LP is not, it's not low enough. You only have 0.1 water depth. That's really, really shallow. Push the LP down a bit. And in this case, you need a wall, okay? You do need a wall around it. Does that make sense? Yeah, you need a wall around it. So double line for that one. And other than that, I think we're okay. You do not need these. Once you have the wall, you do not need these elevations. Okay. All right. Right. So the wall will be at the plaza elevation. And you need some well, the bottom of the wall will be the LP elevation. So you got that covered, but you definitely need a wall over there. All right. Anything else?
That's it.
Okay. Well, you do need to revise your stairs. Okay. Your stairs ish could not be. You start the retaining wall over here. The stairs definitely need 2 flights, right? We can double check. See. Here you have this area. That makes sense. This makes sense. And this area, I'd say it's a little too steep. You kind of need to decide if I want to start my ramp somewhere here, then you would calculate from here to this at 5%, right? My guess is it looks like it's close, but I want you to try to verify it. Reason being, I still want this area to be 2%. I start the steeper slope just for this segment, and I want to make sure this is not too steep there. Okay. I would not do the design like this. I would turn it, right? I would turn it so that you don't need a trenchant over here. Because this area with that little acute triangle, it's going to be really hard to use anyway, right? So it's not worth having a pavement over there. So make sure that you calculate from this, and then this is less than 5 or 5. And keep this at 2%. So that is the top. Let's take a look at the bottom. I wouldn't necessarily, honestly, I wouldn't necessarily start the stair pretty, late. If I want a better space here, no, overall the space here is not very pleasant. If I want a better space here, I might have an enlargement of this and then start the wall over here. So making this space still usable, but no, turning here and then into a relatively narrow and long space. This space, I wouldn't call it pleasant anyway. So I probably would just do, just make it starting from here. And then you would have 2 flights of stairs. Okay. I'm not saying this is wrong. This is not wrong at all. I'm just saying I understand your intention saying, oh, let's have a little bit more space, create a little another space here. But I wouldn't call the space pleasant, even if we open it up like that. Okay. So that's about the slope. Well, we'll need to add side slope to the ramp, okay? Again, this is, you need to turn the contours, all right? Let's take a look at the bottom of the ramp over here. 1107.08. I wouldn't say your building is as high as 1109. Okay, I would say it's probably 108.3 or 5. No, 5 is reasonable. But it's probably not 109.00. And then over here, this needs to be exactly, okay, let's see, 0.5, this works, 98.50 works, 1098 could be here, that's good. And then our bottom of the ramp is too low. Does that make sense? Here you are at 1097.80, and a little bit lower than 7. So this just means that portion is pretty flat. That's okay. That's okay, but your spots here are not correct. Make sense? These spots are not correct. Because we are at about 1097.7 over here. Or, oh, actually even a little bit lower. We need to calculate this. Calculate this to be able to know where these elevations are. Does that make sense? Yeah, this portion is a little too flat, my estimation. Okay. Again, these contours should not hit the wall in that angle. All right. Yeah, same on the other side, okay? The angle of the contours. That works. Okay, that's all I have. Sounds good. Emma, right in the middle. Okay. Do we need to put slopes on every one of our ramps from the parking lot to the plaza? You need slopes for the ramp portion. More they'll be too small. So it does get pretty crowded. Yeah. You would need to include the slope for this one. That slope. Okay.
But
That's
not-
the one.
Not like the other.
You do not need the side flares.
Okay.
Yeah.
If you scroll over to the one that's connecting to my parking lot, I did try and put the slope arrows on there, if you could provide some feedback about
Here.
the readability of that, because I feel like.
Yeah. So first the leader line. The leader line should be really, really thin,
Okay,
right? I would not put the cross exactly on I would put it somewhere here.
Okay.
And I'm trying to figure out what the boundary of where the boundary of the ramp is. So if you have sidewalk over, across the whole thing, then you need to have another 2 lines. You need another line here and another line here. A single line over here, get rid of the curb, and that's a double line. Does that make sense?
so, essentially it's like the second type of.
Right,
ramp that's
exactly.
here. Okay.
Yes. So you would have a ramp like this. Sorry, that's actually. That is a little bit of wall here. And then. Right? So you go down here, go down there, and then people walk or roll from here.
Do I still need the like offset triangles for this type too?
Offset triangles.
Like the diagonal lines. that
Oh,
connect?
no, for this one you don't.
Okay,
Yeah, because this is an option where you can go through. If
Okay.
you have the flares, you won't be able to go through. Okay. Cool. Yeah, and also you have the curb, okay? You have the curb here on the other side and then the curb on the other side. Okay, so that's how you should represent that type. All right. Yeah, compare your contour line here with your cross. Your cross needs to be a lighter type as well, okay? Okay. I'm looking, okay. Make sure even a sidewalk room for the, yeah, we talked through that one. More than 3 ramps from the sidewalk to the, you need 2 of them at least. Yeah, well, 1, 2, 3, right? You designed this one, and I think it's worth doing because you have a sidewalk over here. And then let's just, put a ramp in the middle. Divergence swale. Okay, we'll need to talk about, okay. We don't know yet before you put in the retention. You have to put in the retention and it doesn't look like it's long enough.
okay,
Yeah.
like the swale itself is long.
No, the swell is not pulled up enough,
Oh,
right? If I put a retention over here, then you need to do this. Yeah. So the retention will be tucked in, right? The tucked in between the 2 contours. And, you need to make sure. So if with I would only have a retention that little.
Okay.
So if I need to utilize the space between these 2 contours, I would do something like this.
should I like move my whole swale center line over then? I was trying to, like,
Yes,
really
you will
figure
need to.
out, but- okay.
Yeah, you will need to. I would work on the retention first,
Oh, okay.
and then I would work on my swale.
Okay.
Yeah. Okay. Anything else you wanted me to go through?
Look at my ramp, that's.
Oh, this one. Yes. Yeah,
In
definitely.
terms of like the shape and everything and how the contours did it.
So it doesn't look like it's 3%, to be honest. Reason being that it looks pretty close here and there, right?
Yeah.
If it's 20 feet, we can take a reference from the parking space. That's 20, and I think it's less than 20. Well, if you have 3%, it's actually 33 feet, and I don't think it's 33. So I think you need to check the offset on the ramp again. Um,
Do the contours need to hit the wall and the ramp at like a diagonal, or could you like
Oh,
explain how that
so-
would work?
so the contours. It needs to have a side slope doing like this, right? I can't do a perpendicular like that. Reason being, my water will keep flowing all along the ramp
Okay.
and it will freeze, right? In the winter, it will freeze. You do not want it to keep flowing down. You want it to flowing to the side rapidly off the ramp. So that's, why you need a side slope there. Okay, how do you calculate it? You want it to be 2%. And there's a relationship between the side slope and the longitudinal slope. A quick way is that if this is 5%, if this is 5% and this is 2%, then this length will be 2.5 times of that length. That's how you quickly do the side slope.
Okay.
Does that make sense? So there's a proportion, okay? 5%, 2%, 2.5 times. That's their ratio. And essentially this line will be 2.5 times of that line. Okay?
Okay.
Yeah, so you don't need to go over a really complicated calculation. You just use that ratio. You should be able to do the side slope pretty quickly. Okay? All right.
When I calculate the spots on the ramp, should I start at the top of the ramp and then like work my way down based on the length of the ramp, or should I be like, how should I be doing that?
Okay. So when you are the first thing is definitely correct the contours on the ramp.
Okay.
And then you can be confident that, okay, my calculation of the spots will be good, right? So you start with this. This is the top of the ramp because you want this to stay with the plaza at 2%.
Oh.
Reason being, we are getting down into a stairs, right? So that's part of the plaza extension. And then you start with these spots, and those are the top of the ramp, and that actually seems, pretty flat.
Yeah.
3%, right? So 1106, and this is likely going to be 105.8 or 9 somewhere here. And then you use that to find where the 1105 is, right? You use these to determine where the 1105 is. And then you can keep on kind of offsetting 25 or no, 33 or 20 if you decided you want to go for 5%.
Okay.
Okay. And then from this side, this is pretty reasonable. From this side, you calculate based on the plaza here, and these look pretty good. Now, these look really good. And I don't actually recommend that you extend your ramp like this. I know this is probably sort of a compromise, but it's better if you end the ramp over here. Otherwise, you need to design a little to wall again, right? You're making it, this is 2 walls to go with your ramp because this portion doesn't follow the back plaza. Does that make sense?
If I end the ramp there, then how do people get onto the plaza?
Oh, you end the ramp here, but the plaza paving continues. You do not end the ramp over here. You do not want this slope to be on this pavement, and then the other parts of the plaza is going like this.
So essentially just extend my plaza over to my wall.
Exactly.
Okay.
Yeah, that's a good way to put it.
Okay.
Right. So otherwise you would have to design 2 walls here again. Does that
Okay.
make sense?
Yeah.
Yeah. So this is your bottom of the ramp. Calculate that based on these elevations. This is likely going to be 1096.72. And then use these 2 to determine where 1097 is.
Okay.
All right. And then you go, and then you go up, in your case, you don't have landing.
Yeah, do I need a landing?
No, you don't, because you're all the way down, less than 5%. If you're, I would measure the length along the shorter edge,
Yeah.
not the center line,
Okay,
because you want to make sure that the steepest slope doesn't exceed 5%. So I would measure this line. No, measure this line. And then I would get these elevations, get those elevations, and then do a divide to see what the average slope is. Okay, and then use that to see, okay, I should go actually for 5% and then a small gentle slope at the end.
okay.
Does that make sense?
Yeah.
So it doesn't necessarily, you wouldn't be able to get exact 5% or exact 4%.
Yeah.
So use that to guide if I need a, to make it longer, or where should I put the gentle portion? Usually it's at the end of the slope. So you could, if you need a gentle portion here, you go from the top. You calculate this, you find out what the next contour is, you do 20 feet offset, okay? And then you get down to here, you have the last contour, you calculate the slope based on the last contour and the bottom of the ramp calculation. Right?
Okay, that
Yeah.
makes sense.
Great,
Thank you.
no problem. So we're good?
Yeah, perfect,
Alrighty.
thank you.
Great. Janice. Okay, review the placement of the bar retention area, go over how to know the size of the bar retention circles. The ramp on the right outside of the parking lot. The contours around it. Okay. Find FFE. Okay. Tension on for roof and back plaza. Okay. Curb cuts in the right place for the retention area and the RDIs each. Okay, so let's go from the top. Review the location of the retention area. So one, two, three, four, 5, 6, 7. That's good. And then these two, you might need something in the plaza for the roof. But if you have indication of, the roof goes down here, that's okay too. Let's see. Here, there. One more here. And then, yeah, let me zoom into this area and see what's going on at the corner here. Oh, for this one, you need the cut to be over here, okay? This is a dead corner. This good, that's good. We have one more here. Sure. These ones are good. Well, except for the divergence swell is not designed correctly. All right, the divergence swell is sort of backwards. Not backwards, just like you have to drag this up. Sorry, wasn't drawing it very well. So this one needs to go like this and then go down, okay? And that one needs to go down go up like that. Does that make sense? Yeah, so, oh, sure. Yeah, so the divergence was not correct. That needs to be corrected. All right. These ones are good. Location is great. And the plaza actually goes down here, go down there. I'm not sure what this is for. That might not be necessary. Yeah, this one is not receiving much water. If the trench drain is placed at this location, I don't think this is necessary. Not this one, okay. Okay. Yeah, that's for the location of the retention. I think most of them work very well. The size of the retention, okay. I would say, except for. So at the end of this place. We have a conflict here with the sidewalk. So I would, pull this back, and because you have a lot of space. I actually, at the lower side of the retention, I would make them bigger, just in case, because we're not at a point that we need to recalculate the thing again, right? The point is, the retention area needs to be at least 1/12 of the drainage area. But at this point, we're not going back to our rainbow exercise to recalculate it, so we basically say, okay, an estimate, and so this looks sufficient. But at the end of the chain, I wanted to, as much space that I can feel, I would use that much space, right? So at the bottom here is the same thing. You can either push this a little bit further or extend this to this area. Right? Because this is the end. You want to make it bigger. And it doesn't really take revising much. You just basically change the shape of that contour there. This one seems okay. Well, if I want to do it more sort of more thoroughly, I honestly would extend my trench drain, because this whole plaza is draining to my parking lot. I might just do this. This is oh, you have a drop off. Okay. So then that's not good. You don't want people to stand on the train string where, well, let me think about where. So this trench drain is good because it's receiving all the water upstream for that much, right? And all these is also going to flow down there. So we got this portion covered. But there is a bigger area that we didn't cover, which is this area, right? So it might be good if you have a longer trench drain starting. Yeah, let's do that. I think it's okay if when people are dropped off, they step on to the curb, but the curb, instead of its traditional curb, is a curb with the trench drain. So let's extend the trench drain over to here. Okay. So that's the whole trench drain, and then you have an area here as a retention. If you can make it larger. You have the space to make it larger, so I'm not concerned there. All right. That one seems okay. This one is not necessary. These seems bigger than necessary because you have a relatively small drainage area on the side. So that's kind of about the size. So you did a couple ramps right outside. Are you talking about this one?
Yeah, the one like right off the 88.
Sure. So we have two ADAs. So this is 2 ADA spots. You only need one shading for that. So this is basically one ADA spot is 1.5 regular spot, right? So unless you're making another ADA here, I don't see the need for that one, right? If this is where people get up, you would have a ramp like this. Yeah, you're basically just doing one full ramp. And let's take a look. I think the decision is whether or not this is correct. The decision is actually based on where you end your ramp. Is this where you end your ramp?
It's like
where the curve, like it starts like where, yeah, up there. But I
Mhm.
just couldn't fit those spot elevations closer to up there because of how.
Yes. In this case, you might, well, there's another retention here. Yeah. It's gonna, yeah, it's indeed getting pretty, crowded in here. But essentially what you need, let me make you need one line here. Okay, and one line there. So your spots needs to be put on the ramp because here you're in the vegetated area, right? Yeah, and also, you need a double line for this one because that's a small wall. Does that make sense? And also here, that's a small wall. So you need a arrow here indicating the slope. On this spot, basically this is the bottom of the ramp. You would say BR/BC. Well, actually, yes, BR/BC. And here is TR. And this line needs to be on the outer side of the little wall there. And all this is actually not 5% anymore, right? At this point, you're on the plaza level. So it's gonna be 2%. And you don't necessarily need to label it. Your 2% is actually this direction. Yeah, so no label there. Okay, so that's about this ramp. I know you did another big ramp, so let's take a look here. Side slope, as I explained to other folks. 107 and then 106. This looks like it's gonna be 2%. No, I mean 5%. Again, you start with checking these elevations. Those are the start of the ramp, okay? And then FFE are not right? We're going down that way. So this is gonna be above 07. Right, so I think you calculated backwards there.
Okay.
Yeah, so this,
Because like it goes down on the side, I just wasn't sure how it worked in that upper plaza area. Like, I
so,
wasn't even sure how to really figure out the effort, which is one of my other questions.
right. So basically, this is divided by that line of the ridge line. All the spots on this side will be determined by that contour,
Okay.
right? All the spots on this side will be determined by that contour.
Mhm.
So I basically measure, wherever you enter, right? You can enter from here, which is higher. You can enter from there, which is lower, right? You can choose, say, okay, I want to enter from here, and it's about 1107.5,
Okay.
right? So then once we have the top FFE, we just lower it by 10 and we get these elevations, and then we just calculate based on 2%. All right. So if this is 7.5, that's 6.5. I think we're gonna be at a 95 level here.
Yeah.
Yeah, so we have more and more contour than necessary, which is not a bad thing. We just have a more gentle slope down at the bottom. All right. Okay. So that is the for this one, for the bottom here, you need RDI, definitely. That's correct, right? Those are correct. But you don't have a curb cut there because there's no curb at this point. The lower plaza, you just flow down, right? And then you will say, okay, I'm missing some of them here, which is okay. We're at a vegetated area here. We're capturing most of it. Then that's enough. And then we do need some indication of how the roof it's collected, right? So figure that one out. And let's see what I missed. All right, can you go over how to, yeah, we did that. We did that. Curb cuts. All right, let's take a look at curb cuts. We have these, that, good. Those should be either a DI. Yes, that's a DI, good. This one you actually don't need an RDI, reason being that they can just keep flowing down, right?
Okay.
You do not need an RDI here. That's too small, so we're not using that. That's okay. And then the curb cuts and RDI, good. Well, here you actually need the trench drain. Because we're cutting through sidewalk and the trench drain needs to be here at the lowest point. So those locations are not correct, right? Trench drain and RDI, that's correct. This is RDI, good. And we'll take a look at other curb cuts. So that's good. Curb cut there, curb cut there. I asked you to add a DI here, right? Then you have a curb cut over there. This is not receiving any water. This one is not receiving any water because it's on the opposite side from the flow, right? So this one is good. Let's see. Okay. Keep going on the other side. This good, good, good. That needs to be exactly on the swell. Same thing, curb cut and RDI, good. Good, good. And this one, this is good. Well, I would put it downstream a little bit. So this actually is receiving water up until this point. So I would put it downstream so that I'm receiving a little bit more area. Okay. Yeah, if I'm going here, I'm only receiving that much, right? And so, okay.
Like that fire retention, I got a lot of comments on. But
Cool.
review we got back, so I was still also a little confused on that. On like what each, like what should be on what content.
So the curb cut could be lowered and then this will be about 5.7, something like that. If I base your calculation on this curb cut, you have a CC, RDI works, LP is too low because you know you're at 1.8 feet, right? You don't want to exceed 1. So once we correct that, you would have a 0.5 contour, which you have.
Yeah.
And that's it. I don't see anything else that's wrong. Good.
Yes.
Not sure if we need HP on the plaza.
Okay.
No, you don't need the HP on the plaza. Because you only have a 0.5 contour here, you actually, water wouldn't spill out. So I think it's fine. Cool, all right. There's something. You wouldn't have an HP equal to 106.5 between an 0.5 and an 0.6 contour. So that is not right.
Okay.
Yeah. 0.5 RDI. That is 0.5. Yeah, I think now remove these HP and change the curb cuts and lower the LP. That's what you need. Okay. Alrighty, that's all.
I think so.
Yeah, good. Great.
Thank you.
No problem. Next we have Maxwell. Did I wrong one?
I'm good.
Yeah. You're here?
Yeah.
Okay. How do you recommend I re-implement a retention area in the center of this drop off? Yeah, I think that would be good. A good idea. You have would have curb cuts over here, right? And calculate the curb cuts and use that curb cut to determine the RDI elevation. And then based on RDI, determine the LP. Based on LP, determine the contour number. Based on contour number, look at if you need a high point. Okay. So that is this one. And then, can these bioretention area use the surrounding curbs as high points? Is that something yeah, you could. When you are limited in space, when we're not limited space, we're creating a profile like this, right? And sometimes we need a high points somewhere here. But if we are limited in space, we just create something like that. And this is my curb. And the curb is basically my high points, right? The only thing you need to determine is whether you need high points, between these contours and your retention. It could be because we're sloping down, right? We're sloping down and we have retention areas in the middle like that. But then this slope keep going down in this direction, right? We might need a high point in between here, not in between my curb and my retention, right? So there's likelihood that you still need a couple of high points between your retention and your 108 contour, for instance, right? Okay. So yeah, I would say very likely so. Your high points will be, just in between your retention and then these contour.
Okay.
Next one. How could I put a retention in this portion of the parking lot? I would. So determine where you want your curb cut first, right? I have this portion of the drainage area. You're good in terms of having a curb cut over here, and actually this needs to be a DI on RDI because this is at the end, right? If there's no DI on RDI, water will pond here. So you could do an RDI here. And then this is not a huge area. I would probably just put one more curb cut in the middle. Okay, one more curb cut in the middle. So then your retention area will be in between these two. Okay, in between these two. And then your high point is likely on that side, right? Where we're going down again, right? Going down, and then this is my profile, and then I need a high point in the middle. I'm exaggerating so that the water will not flow down. Okay, so that's basically what you need in between the curbs you need only one of them. And it's good that you have another one here. That's great. So this one, no, that one, yes,
Okay.
because this is at the end. You need.
And there was one there, and I took it away because Sue told me to.
Not really, because this is your contour pattern, right? This is the lowest point. If you don't have an RDI or DI, water would not be able to flow out because this curve is higher than that.
Okay.
Yeah, so you definitely need it one of the two. Okay. Okay. We do need divergence swell here. Your sidewalk actually makes it a little bit more complicated because you need to cut through the curb. Okay, so for instance, if you started from here cutting through the curb, if your retention is in this area, your divergence will actually should shape like this. So the current shape, the divergence swell is not shaped correctly. Okay, so you need one of them here, one of them there. So basically, this would be, this will be here, and your divergence swell would look like that. And then now I know the shape of these, I can better, do this. So you can kind of see your swell of the divergence swell would look something like that. Does that make sense? Yeah. Okay, good. Yeah, those are the two contours that you need here. You have a wall here and this divergence swell. Oh, you have a wall there. if you have the wall there, then yeah, this can just hit the wall. But I don't think you actually need a wall there. You have space. Maybe double check.
I think I.
You have the space.
Calculate the numbers. of the swales.
I don't think you need the wall. You definitely have room to fit in the retention, the two of the retention somewhere here and then somewhere here. Right? And then this contour will just go up. And then that is which number? I'm trying to cannot see which number. If this is 7, then that's 6. Oh, okay. And that, oh, sorry, 8. And then this is 9. So we have an 8 coming down here. 8 needs to go somewhere here. Well, at least you don't need it for 8. Okay. You might need it for the higher one, but your 9 is here. 9, you don't need a divergence swell anymore because you don't have any a retention there anymore. If you want to, you can have one here, but it's not receiving a lot of water. No, forget about that. You don't need this one. Yeah, you only need 2 retention, and then this one will just go down, hit the 10. Oh no, hit the 9. And this is a 10, hit the 10. And 11, 12. I still think you have enough space. Oh, you don't need you don't need the wall there. Because you have a lot of room here for these contours there. Okay. The thing about the wall is that you still have to treat the water coming down to the wall, right? You still have to have a little bit of swell over here, so it's not actually more simple. It's not simpler than what you would propose without a wall. Because you still have to create a swell for directing water away from the wall there. Okay, so that is that one. I would definitely get in touch with Jonathan about line weights, because now I can see, yes, this is a wall. It should be dark, but also I should still be able to distinguish 2 lines of the wall. It's not, instead of one solid line there.
I have one question I didn't put on there.
Sure.
Stu briefly mentioned that he thought my FFB was too high, but I looked at it and I was confused as to.
Yes, the FFE too high, reason being, we're at 107.50 here. In order for the ADA to work, you basically just roll in, right? So your FFE, you could just do 107.50.
Wait, what was that, the number?
Here. You calculated this one and just use that number.
Okay, and then
Yeah.
make that number a swap.
Yeah, make this number, make the upper FFE that number. That's 107.50.
Okay.
Okay,
All right, thank you.
great. Good. I haven't quite looked at the ramp yet. I would say not 5.7, just for, if you have a ramp landing, then that's okay. So we're going down here. This needs to drain as well. Right? This also needs to drain. So this is not an entirely flat area, space.
Can I just make it like 1% or something?
At least 1.5.
Okay.
Better 2, right? Still better if you make it 2. Same thing here. Same thing there. These elevations, 1107.10, those make sense. And then have you measured the length? You cannot exceed a certain length for 5.
I think I did when I made it a few weeks ago.
Yeah, you make sure that the length is under limit. Then let's look at this. This is 1198. Yeah, you got the idea. Yeah, you have to merge to whatever the plaza elevation is, but those two are not the same. Okay, this one is actually lower and that one is higher. Okay, the landing here, you need to decide. All right, let me take it back. This one and that one needs to be merged with the plaza, right? Then you need to decide, the whole thing, how would the whole thing slope? Is it down there or no? It makes sense to slope down there, right? Because this is lower and that is higher. Does that make sense? And use that 2% slope to calculate this and that.
So I couldn't have just done it the way that I did it, where I just had a little ramp going down.
Oh, I think that's too much. Yeah, I think you should get back to the plaza elevation at these locations. Yeah, at least at this now, so you would actually have a little bit of the wall will be extending over, because only at this point you are back to the plaza elevation, and this one you're not at the plaza elevation, so you need to extend the wall a little bit more there. It's just a pretty short wall, low wall there. Okay.
Okay.
Alrighty. Okay. Oh, next we have Pega. So check the ramps, side slope. You don't need to show the side slope. That's the flare. Is it okay that the contour on way across small parts of ramp? Yes. It's supposed to, right? Once your contour actually hits the ramp, it needs to continue to go. And then HP for biotension. Let me take a look at your stairs. Okay, let's see. For the stairs, very quickly, you should not start the first step right there. Okay, you would want to leave a little bit of room here. So once I get, especially when you are connecting the ramp right away here, right? This place will be where you would have more people, multiple people taking different routes, right? So you wanna have a little bit of more space, at least. Well, the requirement is that you have to at least have one step there, because you need to put your feet at the bottom of the stairs and then you go up, right? I would actually make it bigger, right? I would make it more space, like starting from at least there. All right, so that's that. We talked about the side slope thing. Let's put in the side slope for the ramp. And these look good. And let's see, 1108.09, 9809, that's good. And then we have 2% slope going down. Yeah, those look reasonable. I'm not sure what slope here is, so you could calculate that slope and be specific where the 5% stop. Okay. All right. I know we have other questions we need to look at. It's okay. It's okay. You don't have to have. Do you mean the contour goes like that? That is okay. That is okay, because the slope, your water is draining away, and then you have a same elevation. Basically, you have a transition, right? You're thinking, if you think about how this transition over, again, we need a side slope there. And then we need like this. So basically, this is the steepest area, right? And then you just know the transition goes like that. This is okay going around. But I wouldn't have it at 3.7. I would make it 2. Maximum 2.
for the sleep area too, or just max, for example, to.
So if this is your design, you would put maximum slope in this area. You know, measuring from here to there, that's your maximum slope. And then your arrow still is here, but you will say maximum slope, but the slope number should be that one. Okay. All right, so that is the ramp. So I would say, you know, make this 5% and make this flatter. Yeah, flatter. So in that case, honestly, this 2% it should be here. Okay, 2% should be here. If you're 2%, if that's the design, if this is 2%, then that's okay along this line. Even if this has to be a steeper, because if this drops down below 2%, it doesn't drain. Yeah, right. Okay. Oh, so that is about that one. I should check the ramp. We are missing a ramp here. And you have one here, that's good. You have a ramp over here, but I think this is the wrong type. Let's take a look. Yeah, this is the wrong type. You should do the second type because people won't be able to walk through, right? Do you have a sidewalk? Yeah, you have a sidewalk all the way across. So that one, this one actually should be, well, you do need, oh, that's okay. You have more space than necessary for the ADA. You need only to share one. So change this to no shading and add one more line here. So this is one ADA and that is another ADA. Okay. And then your ramp should go like this. Does that make sense? Yeah. This. No, it wouldn't. This is the flatter part. This is the flatter part. And you're going down here. Sorry. You're going down here and then you're going down there. So that way it wouldn't obstruct people's walking. Right? You cannot have a side flare over here. People won't be able to walk through, right? If you go down and then the flat and then go up. This is the ramp. Yes, that's a landing. I'm sorry. No, you do not have the flare. Yeah, yeah. So this is the other type of the curb ramp. Okay, good. But this one, yeah, 6% work. 6 point, not yeah. So the BR and these all look good. Yeah, that looks good. Okay. It's a little strange where you have sidewalk, you know. I don't think let's make a little bit of change. So you actually would, I don't know if you have seen, I think it was Emma's she was trying to incorporate. You do not want people to walk here and then find out, okay, I cannot walk through anymore. Right? You have a sidewalk. So oh, okay. I think I know a better solution, a more simple solution. Get rid of this line. Get rid of that line. Wherever, let's see. Basically, once I'm down here, I am on the plaza. So I do not need that line unless I want this to be a different paving. Yeah. If that's your intention, that's okay too. But it's just a little bit strange to see, you know, I can't actually walk here. I have a different paving, but once I get here, I need to stop, right? So you can simplify the paving that way. It's totally fine without this line. I just stop here, right? I stop there. Okay. Going forward. HP in the parking lot. 107. This one? Oh, here? You do not need to mark. Do not need to mark HPS anymore. You just mark the elevation. Yeah, because this is just one swell. It's one swell. It kind of came in and then it starts again. And this is not necessarily.
They mentioned that I should put SPS on
You have a HPS.
Yeah, one more time they said that I should put FPS on SPS.
Okay. Let me check with Stuart and see if he agrees with that. In the
And also, they said that I put the line of the sewer.
yeah, remove this line, right? That's correct. But he said we have to start marking HPS again. Okay. All right. I'll let him know that I said a different way, but we probably, if that's our fault, not being unified, then we will not mark points off at the end. Okay.
For the SPS, for the other bioretention was done.
For the other bar retention on the top, this one?
Yes.
Okay.
Last session, they mentioned that I changed the TC to TCHP in the downside. So the bioretention goes. But I'm not sure that it's correct or
Here?
not. Yes. I'm not
Oh,
sure.
okay.
I don't know that other side also I should change the TC and HP.
On this side, it's because the curb are used as the HP. So I think this makes sense. Now having a TC/HP.
For this,
For this one, yeah, for this one it does work because you're using the curb as the high point, right? Yeah. If that's the case, these ones are the traditional HPs. Do you mention do say you have other areas that has the same comment?
What?
So is this the only area you have question about the TC/HP? Yeah, this works.
so for these two bioretention, the HP should be TC and HP.
Right, for this one, yes, for this one, because you're using the curb as the high point. Yeah. Yeah, but for other areas, if you're not using the curb, then you would not need to do that. Yeah, okay. So stairs in the plaza, we took a look there. Oh, 108 crossing the ramp. Where's the 108?
The one that-
Here?
Yes.
Oh, in this case, you wouldn't, because you have this wall there. Well, there would be a little bit portion of the 108 there. So if this is the case where I have the ADA kind of come down here, I have let's see, I only need that much, right? I have a landing here, and then my curb actually is here. My curb will continue, and this is the ramp. Then you would have your 108 go here, right? And then it kind of continues over here. And where is the 108 coming out? I need to find out where 108 is on the other side. It's kind of here, right? I need to, so it's out of your ramp. Yeah. Well, it goes along here, right? It goes along here, but there's a portion that is on the ramp indeed. But you have a little bit of curb over here. You do need to find out where 108 it's on this ramp by calculating this. And these spots, a portion of it, my guess is it's gonna do something like this. And then come out, depending on where you set the curve around your, then it continues out here. Does that make sense?
It's going to be on the ramp.
Yes, it will be on part of the ramp, part of the ramp, and then go along the curb and then continue out. Yeah. Yeah, seems like this is that, right? Yeah.
Did not like you cross the ramp?
It has to. Yeah, you wouldn't, it has to be connected, right? So definitely there's portion that's on this wall. Because you basically move the curb and had another curb over here. Yeah, and then in order to connect this, it has to go like this. Yeah. Okay, great. So that is the ramp question. I think that's it. Alrighty.
And it says, so
So
Okay.
the stairs, we took a look at the stairs. You have the TS and TS here calculated based on the plaza. It's 106.87. They would be different. Yeah, they would be different. So, oh yeah, you have it. Okay, so that's 06.78. Okay. And we have 8 risers, 9 treads, and then we have, yeah, 2% slope. Yeah, this needs to be a 2% slope.
I thought it's flat. So,
It needs to drain. Otherwise, in the winter it freezes out up and then it's dangerous, right? So yes, that there needs to be a 2% slope, but on the landing there.
the side is so- like there are also
The side slope, you mean the stairs? Yeah, you need to show a side slope, right? Cool. Good work. Alrighty. Next I have Nicholas.
Yes.
All right. How do the curb ramp look? Well, this work. You have a BR and I think there are some leftover lines when you were calculating yeah, that's okay. Just remember to put it on a different layer, then you can turn it off now altogether. So BR, it feels okay from this point on. Yeah, that seems right. The calculation seems right. And then this one, 8%. Well, I would let me ask, how did you calculate the TR here?
From I started by calculating the ramp.
Mm-hmm.
and doing the 8%.
Oh, okay. Well, I would recommend treat this as part of the plaza. So basically what you do is you can calculate this based on that, and then you add the curb height. Okay, so pretend that it's at the plaza level. So basically once you get up the ramp, everything follows the plaza grading.
Mhm.
Yeah,
Right, so wait, you said calculated from the 1,000 contour,
and then add 0.5.
and then add, okay,
Yes.
gotcha.
Yes, and you can also do it based on your plaza contour, but your plaza contour is a little hard to find, right?
Yeah.
Yeah, so I think just calculate that based on the 1109 and then you add 0.5, so it should be good. Okay. Great. This one, I think it's the same idea. Remember to get rid of the line there. Remember to get rid of the line there, and your trench drain should stop here. It could not be kind of, here it not conflict with the ramp, right? Yeah, you would stop the trench drain somewhere here and then restart it over there. It's okay that way.
So wait, you said just stop it in the.
Right, this is your trench drain on the other side.
Right.
And this is, no, the other side, but you wouldn't have a trench drain At the bottom,
Yeah.
they're connected,
Yeah.
but at the top, you wouldn't have it.
Okay.
Yeah.
Just because in my like red line,
Uh-huh.
example four, they told me to just do like a straight drain on the left side. And I know
Let's
this one
see.
told me to do it kind of around the bus drop off.
Let's take a
So
look.
I,
So the reason we have, let's see, everything, yeah, goes in here, which is good. This one needs to, yeah, we don't have space here for that one to collect. Um, how about if we move the ramp a little bit over here and just say, you know, this portion, I'm just not gonna worry about it. And then the trench starts from this side and that goes in here. That makes sense? So that your ramp is not interrupting your trench drain.
gotcha.
Yeah, if you have, you know, in your previous case, if you have a trench drain over here, it actually makes sense to dump it somewhere here, but you don't have the room, right? Yeah. So I think moving your ramp to over here actually works.
Okay.
Yeah. All right. So that is the yeah, that's the ramp. Okay, you have another ramp over here. That works. You seem to have more steps than necessary, but maybe that's 20. And I don't think you need so many steps, so many landing. You can simplify it by having 10 per flight.
Fine.
Yeah, 10 per flight. So then you can simplify your stairs, you know, by not having 4 landings to grade. Improve the ramp here. Okay. I think the ramp contours needs to be, you know, improved, right? We went through how to calculate it. But I would say uniformly, I would have a 5% slope, having a side slope there, right? From this point on, it's not uniform anymore. So you need to make them uniform. And here it needs to be 2% when turning. So calculating from the top and then calculating from the bottom and see, you know, where the other, so for instance, no, the contours land here, then this portion will be 2% or even, no, yeah, between 2 to 5 would be okay. Now, you do need to verify these elevations to calculate from the bottom. Does that make sense? So for instance, if this here is 0.6, you would measure how much? Actually, 8 feet, right? 8 feet is 5%, 8 feet to get to your next contour. If here is 0.2, you would measure how many? You 16 feet. So the distance, the spacing here, for the first contour is determined by these elevations.
It's determined, okay, by the.
Yeah, by these elevations on top of the ramp, right? It wouldn't be, you wouldn't get to the integer numbers at this point because unless this contour hits here, which is not the case. So the top of the ramp needs to be calculated by that contour. And then you find out what's the next contour. And you find out what's next contour here, based on the bottom of the ramp elevations. That makes
And
sense?
so when
Mm.
finding like the next contour, will I use just take the slope number and then. calculate
Yes.
Based on that.
Yes,
Okay.
yes, exactly. So we're not at 10 feet difference here, right? If the top of it is 109, 8, the bottom should be 98. And let's take a look at the top there. So we are at this elevation. What's the number? Make it, even if you only have a very small contour here, make sure you label it because I'm trying to find out the elevation here and I'm not able to, right? So if this is a 7, I think this is an 8.
Yes.
Yeah, if you have an 8 here, you might have another. This is kind of. there's something off about your ridge line. So can you see that if I'm offsetting 50 here? I am, oh, actually, it kind of works. Okay. You might be missing a contour here.
Okay.
Yeah, if this is 8, that's 9. Your top FFP will be above 9. Does that make sense? Yeah. Above 9, so this is 1099, and then based on that, this is probably at about 98.
Okay.
Okay. Somewhere around 98 there. So that is about the ramp. Anything else you want me to go through?
I guess the last thing is before where the trench drain comes out and I provide retention. to
Mhm.
the bus stop, is that all like correct? Cause I just didn't, I wanna make sure I didn't like. Do it wrong before I continue.
Okay, so your trench drain would not extend over to here.
Okay.
I mean, let's see. It could come out. So this is all collecting. Yeah, it could come out of here. And you just need to find out the elevation here, right? You can see I am high here on the plaza, but the trench drain kind of needs to be flowing all the way down.
Right.
Wherever you start.
Right.
Right? So you could start with this elevation at the top of the plaza, and you find out the bottom of the trench drain by doing the minus 0.5.
Yes.
And then you measure this length. You measure the length of the trench drain, and you go down all the way 2%. And then that's your bottom of the trench drain elevation here.
Gotcha. Okay.
Okay, yeah, it's a little winded. Also, no, honestly, it will be easier to say, I'm just gonna, this is high. There's a way to say I have a pipe going underneath, to treat this portion, but honestly, it's hard to repair. So I still think this is better. So going all the way down here, it's a little long. What I mean was the trench drain's a little long. If something got clogged in the middle, then you have to find a way to clean out.
Yeah.
But even if that's the case, repairing a trench drain that you can see is easier than repairing a pipe that is buried underneath the pavement. Okay. All right. Okay, anything else?
No, I think that's all. Thank you.
Alrighty. Okay. I think I have one more. Is Graham here?
Yeah.
Okay. So let's see. Need to rotate it. I'm trying to find retention. So your retention right now, it's at a higher elevation, okay? The water goes in this way, so your retention is not on this side because water is not flowing in, right? You can play that water drip. So if I'm a drip of water, even if I start from there, I flow down. I would not flow into my retention here. Okay, so your retention area should be somewhere here. Okay, these are your retention area. And this could be turned into one, although the area is not too big. At the end of so the lowest point, you need something that comes out of the curb as well, right? So that's so those two are not at the right location. This one is in the right location. We take a look at the calculation here. So the curb cut, I don't know the curb cut elevation here yet. you need to calculate that curb cut elevation. Now it might be at 8.8 or even 8.5. Okay. And then your RDI is a little low. Well, I take that back. You actually need to cut through your sidewalk. Cut through the sidewalk. So your the bottom of the trench drain here might be at this elevation. So RDI seems to work. And then your LP is 107.7. Water depth is not very high. You can put the LP lower so that you have enough volume storage. And based on the RDI, you have a 108 contour. You definitely need to label the contour. Okay, label the contour. You have an 8 contour, and your HP needs to be between the 8 and your 8 over here. Right. So your HP needs to be on the side. So that is the retention area. All right. So the couple information missing. All right. That is this retention. And we need to work on the divergence swell. So far, we don't have one yet. We need to work on the ramp. So we went through, sort of how to calculate it. We don't have contours here on this side. We have a few contours here, but I'm not sure if they are at 20 feet spacing. Well, I think it's above 20, compared to your parking space here. Okay, so you really need to start from the plaza elevations here based on that contour. And then your bottom of the ramp elevation based on this elevation and the 2% slope down. Okay. And while I'm seeing that, I am a little concerned about the contours here on the plaza. Yeah, this 105 is not correct. And your 106 being here, your 105, that should be a 106. And I think this needs to go up there. And you have a 105 somewhere here. And this is your swale. Your 106 is over here. So your 105 should be something like this. Okay, that's your 105. And over here, I don't know if this is well, that look like it's it. And then there would be something over here. It's probably a closed contour inside. Or, well, if you do the 50 feet offset, it might be, might be looking like that. And this kind of comes down back here. Does that make sense? So your 05 contour and 05 contour on the plaza are not correct yet. So first you need to correct those. Then you will know what the elevation here is. Okay. And based on those 106 contour, your top FFE should be above 6. All right, above 6, close to 7, based on these calculations. Using that top FFE to correct the bottom FFE, calculate these based on the 2% slope, and then you can start grading your ramp. Does that make sense?
Yeah.
Okay. All right. Any other questions?
That's it.
All righty. Thank you.